So let's say that 1 to the third plus 2 to the third, and then up to n cubed, let's say it's equal to n squared times n plus 1 squared divided by 4. So let's show that it's true for n equals 1. So 1 to the third, that's going to equal 1 squared times 1 plus 1 squared over 4. Let's see if that's true. 1 to the third is 1. 1 squared is 1. 1 plus 1 is 2. And 2 squared is 4. 4 divided by 4 is 1. So it's true for n equals 1. Now let's try another one. N equals 2. So we need the sum of the first two terms. So 1 to the third plus 2 to the third power. That has to equal 2 squared times 2 plus 1 squared over 4. 1 to the third is 1. 2 to the third is 8. 2 squared is 4. 2 plus 1 is 3. And 4 divided by 4 is 1, so we can cancel that. 1 plus 8 is 9. 3 squared is 9. So it's true for the second term. If you want to, you can test out the third term. But this is enough for now. So we're going to assume that n equals k, and it's true when n is equal to k. So we're going to have this expression, 1 to the third plus 2 to the third plus k to the third. And that's going to equal k squared times k plus 1 squared over 4. Now, assuming that n equals k is true, or that the equation is true when n is k, we need to prove that it's also true if n is k plus 1, the next term. So we're going to have 1 to the third plus 2 to the third, and then k to the third. The next term after k is k plus 1. Now on the right side, everywhere you see a k, replace it with k plus 1. So this is going to be k plus 1 squared, and then replacing this with k plus 1, that's going to be k plus 1 squared divided by 4. Now we need to prove that the left side of the equation is the same as the right side of the equation. Now what do you think we need to do next at this point? Now recall that this side is equal to that side. So therefore we need to replace everything up to k to the third with this expression. So we're going to have k squared times k plus 1 squared over 4 plus k plus 1 to the third power, and that's going to equal what we have on the right side. So how can we show that this expression is equal to that expression? Well, the first thing I prefer to do is combine these two into a single fraction. So I'm going to multiply k plus 1 to the third power by 4 over 4. So now I can write these two as a single fraction. So it's going to be k squared times k plus 1 squared plus 4 times k plus 1 raised to the third power divided by 4. And that's going to equal k plus 1 squared times, I can add 1 and 1, which is 2. So that's going to be k plus 2 squared divided by 4. Now let's get rid of the fractions. So I'm going to multiply both sides by 4. So these will cancel. Next, I'm going to take out the GCF, k plus 1 squared. If I factor out k plus 1 squared, on this side I'm going to get a k squared. Here, there's 3 k plus 1s. I took out 2, so there's 1 left over, and there's a 4 in front of it. So it's going to be plus 4 times k plus 1. We don't have to make any changes to the right side. So I'm going to keep it the same. Now, these two are already equal to each other, so I got to show that this expression is equal to k plus 2 squared. So let's begin by distributing the 4. So 4 times k, that's 4k, and then 4 times 1 is 4. Now, we have a trinomial that can be factored. So we need to find two numbers that multiply to 4 and add to 4 at the same time. So that's going to be 2. 2 times 2 is 4, 2 plus 2 is 4. So we can factor as k plus 2 times k plus 2. And so we can rewrite the left side as k plus 2 squared. And that's equal to the right side. So we've shown that the left side and the right side are equal for the next term, k plus 1. So therefore, it's going to be equal for all terms. And that's how you can use mathematical induction to prove that a certain expression is true for any term.